So in a traditional full round-trip request-response style application where you have a full page refresh on each navigation, restoring scroll position is actually fairly trivial because the browser just does it for you. Unfortunately, in a single page application like an Angular application, especially one in which you might have multiple router outlets as siblings, dealing with scroll positions, specifically restoring and retaining scroll positions, becomes, in my opinion, a very non-trivial task. So for the last couple of weeks, I've been working on something on a Polyfill module to try and handle some of this scroll retention for you. So just to demonstrate, let's get a sense of what this application is here. It's just a simple application with a list here, and you can see that these load dynamically, and they're kind of simulating network latency. So this is the primary outlet. Section C here has a little tab section, and then I also have these secondary and tertiary outlets so that I can do parallel navigations, alongside my primary outlet. And so each one of these outlets has potentiality for scrolling away from the top here, and ideally what we want is something to then maintain these scroll positions as we move backward and forward through our browser history, as well as we navigate through router links, scrolling to the top when necessary. So first, let's look at the simple one, which is, let's say I'm at a scroll or a scrollable position here, and I scroll down, and then I want to scroll to another outlet. As you can see, I've been scrolled automatically to the top of the page, even though the browser would have liked to have kept me at the same offset as the previous view. Now, this doesn't always happen, right? If I go from B to A, no problem. If I go from A to C, no problem. I'm scrolled to the top. But at the bottom of C, we have these tabs again. And you can see here that as I scroll from tab 1 to tab 2, which is another segment in the router outlet path, I'm only scrolled to the top of the particular router outlet. I'm not actually scrolled to the top of C. Similarly, if I open up one of the secondary outlets, you can see that my changing offset here is not affected whatsoever. And of course, if I go into something else and then I go back, you can see that I'm scrolled to the top here, right? Similarly, if I go here, I'm scrolled to the top, even though I have enough padding here to allow for scrolling. So it's scrolling us back to the top as we move forward. But to me, that's almost the less interesting part of this. The more interesting part is the restoration of the scroll position as we move back through history. So let's, as an experiment here, go to section A from the home, and I'll stay at the top position of A, and then I want to go to B, and I'm going to scroll halfway down B, and then I go to C, and I'm going to scroll halfway down, or all the way down C, and I'm going to go into a tab here, and I'm going to scroll down to the bottom of the tab, and then I'm going to open up the secondary and the tertiary, and I'm going to scroll down to the bottom of the second one, and I'm going to stay at the top of the third one, but I'm going to scroll into it. So we had A scrolled to the top, B scrolled halfway, C scrolled all the way to the bottom with the tab open, scrolled to the bottom of the tab, secondary list scrolled to the bottom, tertiary detail opened. And now if we go back to home, right? And now if we go back, you'll see that these scroll positions have all been maintained. I'm at C, I'm at the bottom of C with the tab 2 open, I'm at the bottom of the secondary list, I'm at the top of the tertiary, and if we look at the console, what you can see here is that it was attempting to reapply page state based on these CSS selectors and offsets. Now, if I go farther back, you can see that we continue to go through history. You can see the scroll positions are being maintained. Right, so I'm at the bottom of C. If I now go, I should be at halfway through B, and there I am halfway through B, and if I hope I'm at the top of A, and I'm at the top of A. So it's maintained the scroll positions as we've gone through. Now, because I've been resizing my browser, that may count as scrolling, I'm not sure here. But now if I go forward through time, I'm actually halfway through B, all the way through C, C tab, secondary list, does it scroll to the bottom? Scrolls to the bottom, tertiary list, tertiary detail. So you can see it's also attempting to maintain that scroll state as we go back through, or back forward through history. And then of course I can continue to do things as I would, right? Halfway through A, now I'm at B, now if I hit back button, I should be halfway through A again, boom. All of this was incredibly non-trivial for me to figure out. And I've tried to set it up in such a way that it's fairly seamless to integrate into the application. So let's take a look at what it's actually doing at the code level. So here is my application module, where you can see I'm setting up all the routes. None of these view components are particularly interesting. Really what we want to get down to is our module imports. And if we go down to the imports section, you can see that I have my router module, but what you'll see here is I have my retain scroll polyfill module. And this essentially, this import statement right now, is the only thing that my application has to know about in order for all of the functionality that you just saw. I'm not adding any additional logic to these views. I'm not adding any additional logic to my root component. It's all right here in this polyfill with, again, the hopes that, as with all polyfills, it can be removed one day and perhaps Angular core can actually implement all of this functionality on its own. Let's take a quick look at what the polyfill is, but I'm going to defer to you guys mostly to look at it on your own because there's quite a bit amount of code here. But if we look at the retain scroll polyfill module, what we can see is that there is a directive and there are a couple of services that it uses internally. Each piece of the polyfill is handled by a different portion of this module. So the router outlet directive override, that handles the moving forward via router links. So for example, if I have my tertiary here and I'm scrolled down and I go to a new thing, the fact that I'm scrolled to the top here, that's being handled by that directive. The fact that I can hit back and be scrolled down in the list, that's being handled by this retain scroll polyfill service. And then both of them depend on this DOM utils, which you could theoretically override if you want to fine tune how some of this works. The polyfill service is fairly complicated, and I've put in a ton of comments here to explain both to myself how this works, because it is fairly confusing, and to anyone else who wants to read. But essentially, it works by monkey patching the history API so that it can keep track of the state as Angular pushes state onto the history stack. And then we also bind to the pushState event so we can listen to it. But let's take a quick look at the let's see, the history API pushState. Let's find where that is. Okay, no. Yep. Okay, so here when we initialize this service, we monkey patch the pushState API. So you can see I'm grabbing the pushState, I'm storing it, and then I'm running outside of the Angular zone, right? So we have a bunch of things here that we don't want to trigger change digests. And I create a new pushState function, which takes the state and eventually passes all of this through to the core pushState method that I'm overriding. But you can see here that the state value that I'm providing is essentially overriding whatever state was passed in. Now, at the time of this writing, Angular always passes null in through this method. So of course, if Angular ever passes something other than null, this polyfill becomes unacceptable. But hopefully they're doing that because they're trying to replace what this polyfill is trying to import. But essentially what you can see here is that I'm adding an ID to the history stack, and I'm generating a new history ID every time pushState gets called. And essentially this history ID is how I then associate the page state with each entry in the history. And there's a whole bunch of stuff, but essentially what we can look at, let's take a quick look at how we handle navigation. Here it is. No, sorry, quite a bit of code here. Yep, set up router bindings. So the way this works is, well, one, it listens for scroll events and it captures the state of DOM elements after a person's been scrolling. And then essentially we look for the navigation start events and we take all of the elements that have been scrolled and we store them in the current element state associated with the current point in history. And then once the navigation ends, we check to see if this is a pop-based navigation, meaning I'm going either forward or backward through my history using the browser navigation. And if that's done, I grab the page state out of the history and then I try to apply it to the DOM. And I'll let you guys look at the details here because again, this is a ton of stuff. The other interesting thing here is the router outlet directive that I provide. So of course the Angular router module provides its own router outlet, which is how it manages all of its rendered view components. But I can bind to this as well, and when I bind to it, I'm actually injecting the sibling instance of router outlet. So this is the core Angular router outlet instance, and I'm taking it and I am listening for its activate and deactivate events. So when the route changes and the router outlet has to destroy a view component and then potentially add another view component back into the DOM, I go ahead and I keep track of the current page offsets. So when a component is being destroyed, I grab the parent element of the router outlet, so essentially the container of the view that was just destroyed, and I start walking back up the DOM and getting the scroll top of any element node that I come across, and then at the top I get the scroll top of the window itself. So essentially every time a view is destroyed, I get all of the ancestral scroll tops with the destroyed component not rendered, which means that anything that needs to be scrolled up to the top to close in the gap that that component left will now be recorded. And then once I detect an activate event, if I have any offsets recorded, I then do the same thing where I start at the container and I start walking up through the descendants and I come across anything that's an element and I try to scroll to the particular offset for that particular element. So this way, even if a new view wants to let the browser scroll down, I'm going to go ahead and reinstate the scroll that was there when that component had just been ripped out of the DOM. So this is kind of the second half. And then of course both of these depend on this DOM utils, which mostly is there to sort of differentiate between window and element based scroll tops, right? Because window has scroll Y, elements have scroll top. With an element I can just set the scroll top. With a window I have to use the scroll to function. So this is just trying to abstract that away and make it a little bit easier. The one most questionable part of this is that I generate CSS selectors based on given targets, and I do that again by walking up the DOM tree and looking for encapsulated CSS attributes. So those underscore ng host, right? If we look at the top here, these underscore ng host and underscore ng content attributes, I'm looking for those and I'm using those to generate a CSS selector. And if we look at the if we look here at the console and you can see that it's attempting to reapply page state, you can see that the selector here is myapp ng host c0, tertiary view ng host c4, and those these attributes here relate or reference the encapsulated CSS attributes. So, you know, this polyfill makes a bunch of assumptions that you're using pushState, that pushState's available, that you're using encapsulated CSS, that you're not passing anything but null into the pushState API. There's a bunch of things that it has to depend on to get anywhere close to being functional. And I've only really tested it in this kind of a context. I don't actually know how battle tested this is. But if nothing else, hopefully this inspires someone else to maybe come up with something that's more robust or hopefully more simple. But again, restoring scroll positions and retaining scroll offsets in a single page application like in Angular 5.2.3, I found it to be incredibly non-trivial. And hopefully one day Angular core just does this for us and all of this complexity is made moot. But until then, I will continue to explore avenues like this to see how I can make my routing applications a little bit more user-friendly.